All right, good. Okay, so now this next video will probably not be quite as long. We're going to talk about the first planet, the planet closest to the sun, and that is Mercury. So let me bring up a picture of Mercury real quick. So here we go. Now, these are not both pictures of Mercury. The one on the left is a picture of the moon, and the one on the right is a picture of Mercury. And they are roughly the right size compared to each other. And you can see here, Mercury's not that much bigger than the moon is. It's actually the smallest planet. And in fact, if I had not had the text down here at the bottom, you probably would have had a hard time telling me which one was Mercury. Okay, so Mercury has a surface that looks a lot like the moon. So what's the most prominent feature on the surface of Mercury? Craters. We said this a little bit further back in this. Mercury has the most craters, or at least the densest craters. It's the most densely packed with craters of any planet in our solar system. So number one, the first number one feature on Mercury is craters. Now, why does it have so many craters? Well, again, remember, Mercury is very small, so it lost a lot of its heat. So it never got a chance to do almost any volcanic activity. There has been some evidence that there are some very small, very old dead volcanoes in a few places, but basically it's pretty volcano free. So it never got a chance to erase craters. So craters everywhere, okay? Other than that, like we just got done saying, there's not going to be mountain ranges here. And if it never really got to form volcanoes, it's not going to have a lot of mountains. So overall, Mercury, very flat. And so the land between the craters is just called flat land, but it uses the technical term for flat land. So what we call the land between the craters is the intercrater plains. So let me get that up here. The intercrater plains. And all that really means is plains means flat land, and intercrater means between the craters. So what we call the flat land between the craters, we call it the intercrater plains. Basically all it is. But it's a very, very, very flat planet compared to Earth. Okay, now, a much more interesting feature on Mercury is one that you probably cannot see very well. Remember, this is a picture from your book, so you can zoom in on this picture if you look in your book later. It's in chapter 7. But yeah, look for that. But if we look really, really, really close, there's a couple of little, what looks like long, wrinkly lines crisscrossing across this. Let me see if it's a little bit easier to see in the next picture. So this is a close-up picture of one of the craters. And if you look real close, let me see if I can point it out. There's some wiggly lines coming across. Now, some of these are from the crater, but you can see here some of these wiggly lines are going across here. And those wiggly lines can extend for miles and miles and miles and miles. Now, don't worry if you can't actually see it. You might have to just trust me on that. But those long wiggly lines are called hills. Or wait, sorry, they're hills. Long wiggly hills. And they're called scarps. So let me write that up because that's probably a word you've not seen before. So the long wrinkly hills are called scarps. And those formed in a different way than hills do on Earth. Because hills form on Earth from plate tectonics. Okay? Hills form on Earth from plate tectonics. But is there plate tectonics on Mercury? We already said no, right? So how did these form? Well, these must have formed really, really, really long ago. Very early on in the history of this planet. And what we're pretty sure happened is, remember, compared to the other planets, because Mercury is very, very small, it cooled off much quicker. Does that make sense? It cooled off much quicker. Does anybody know what happens to the size of rocks as they cool? Let me put that up in the in the chat. What happens to the size of rocks as they cool? Yes, somebody said it. They get smaller. They get smaller. So what we believe happened is that as Mercury first started to solidify, once its crust fully solidified, because it was cooling down so quickly, we believe the crust shrunk. So can you figure out what the scarps are if the crust shrunk? Why are these long wiggly hills all over that crust? What about shrinking could make wiggly hills? I think you guys might be overthinking a little bit. Let me give you a metaphor. Oh, there we go. Rock has a hard time compressing. That's part of it. Think about a grape. If you shrink a grape, what do you make? What do you make from a shrunken grape? Like if you dry that grape out. A raisin. And what do you got all over the surface of a raisin? Yeah. Yeah, that's it. A raisin is covered in wrinkles because the surface couldn't shrink uniformly. So essentially, the scarps on Mercury are raisin wrinkles from the shrinkage of the planet. So let me, I think I have a picture that shows that. So if you look right here, they're trying to show that as the planet shrunk, its surface got all wrinkled up. Does that make sense? All right. Okay. Now. Oh, and by the way, yeah, we'll get to that in a second. Okay, so scarps are raisin wrinkles. So if I ask, how did the scarps form? You can basically tell me that Mercury shrunk like a grape shrinks when it forms a raisin, and the scarps are just raisin wrinkles on the surface. It's a little bit different than somebody asked if the surface of Mercury dried out. There, my metaphor is breaking down a little bit. Here, the surface is shrinking just because rocks shrink when they get colder. And they grow when they get hotter. So it's not necessarily that the crust is drying out here, although it is solidifying. Okay. All right. Okay, so here's the next question I have while we're talking about the inside of Mercury. Let me show you some pictures that compare the different planets. And if we look in here, on all these pictures, they've combined the two cores into one, just so that they can compress the picture here. So on Earth, we've got both cores, the mantle and the crust. And what do you notice about the pattern on Venus compared to Earth? They're roughly the same. Whereas on Mars here, again, still roughly the same. In terms of proportions, crust, mantle, core, same basic proportions. But what do you notice about this cutout of Mercury here? Mercury is, one of those layers is much thinner than it is on the other planets. Which layer is different here on Mercury? Yes. Somebody got it. Clearly, Mercury's got a whole bunch of core, not a lot of mantle. So compared to the other terrestrial planets, the iron content of Mercury is much higher. And we're not yet fully sure why that is. We just know that overall, Mercury has a very high density from all of that iron. And the prevailing idea, the prevailing hypothesis, although this hasn't, it's not unanimous yet, is, remember, all of the planets formed from large, essentially chunks of rock and metal slamming together. And what we think happened to Mercury was when just before it fully formed, when it probably was actually a little bit bigger than it is now, but it was hit by something at least half its size, maybe even bigger. And normally we think of these kinds of collisions causing very big craters on the surface, but that kind of impact probably completely destroyed Mercury. Okay? So we think that at some point, Mercury was completely torn apart by a collision. And I see a question up there. I'll come back to that in just a second. And compared to the other planets, does Mercury have as much gravity? No. So what we think happened on Mercury is because the gravity is so low, the lighter materials essentially flew away because of the impact of that collision. And the heavier materials stayed behind. And what's heavier, the iron or the silicates? Yes. A couple of you guys are getting it. It's the iron. So the iron, it was easier for the iron to stay behind and reform a new Mercury. And only a little bit of the silicate material stayed behind to form the Mercury we have today. And like we said earlier, the stretching of the planet from the sun keeps a little bit of that core, just tiny bit of that core, artificially still liquid, but it's so deep down that it can't form things like volcanoes. Okay, and somebody asked if being much more iron contributes to it being more easily stretched by the sun, and I'll just be honest, I am not sure on that. So I won't be able to answer that particular question. Now, somebody's asking, how did scientists figure out that Mercury was destroyed and reformed? Remember, I said that was the leading hypothesis. We do not yet have proof that happened. But we do know that the planets did form from collisions. So it makes sense that something like that could have happened. And that could be a way to explain why this is. But again, we don't know for sure if that happened. Although in computer models, we can figure out if that was the scenario, what would Mercury have to have been like, and what would it have to have been hit by to end up the way it is now, and all of that lines up with things that are at least plausible that they could happen. So yeah, I can't say for sure that happened to Mercury, but that is the leading idea at this point. Okay. All right. Now, here we go. So we're done with the inside of Mercury. There's not too much more to say about Mercury. Remember, does Mercury have an atmosphere? We talked about this in class. Does anybody remember if Mercury has an atmosphere? Oh, so while you guys are answering that about the atmosphere, somebody did have another question about how do we know how big the core is. If you remember in class, we said that we can compare the density of the material on the surface of the planet to the overall density of the planet. And by comparing those two numbers, because Mercury's average density is a lot higher than the surface, we know that the stuff inside has to be much more iron rich than inside the other planets. So it's basically by looking at average densities compared to surface densities. And are we 100% exactly right about exactly where the core cuts off? Probably not, but we're at least close. Looks like we might have another question coming in. Oh, that was that over there. Okay. Now, so Some of you were mentioning that Mercury does not have an atmosphere, and that is basically correct. There's some wispy gas here and there, but not enough to really be called an atmosphere. And that's because Mercury it has such a low gravity, it has a hard time holding gas down, and it's so hot because it's close to the sun that the gas that is there tries to move around so quickly that it's easy for it to fly away to space if you're not good at holding it down. So too hot at the surface and not enough gravity. So there's not an atmosphere. Now, what kind of temperatures would you expect Mercury to have? Yep, hot. And why is it so hot? Because it's close to the sun. The average daytime temperature of Mercury is around 660 degrees Fahrenheit, although some parts near the equator can get up to around 800. So Mercury is very hot. So are we ever going to land anybody on Mercury? No, we're never going to land anybody on Mercury because they would absolutely die. They would burn to death. So a lot of people say, okay, if it's too hot on Mercury, how about I land on the nighttime side? Because what happens to the temperature at night? It gets cold. Would you want to land on the nighttime side of Mercury? And why not? I'm going to say, no, you don't. Why not? Why don't you want to land on the nighttime side of Mercury? Yeah, some of you guys are getting this. Even though we think of Mercury being a very hot planet, the nighttime side gets down to negative 260 degrees on average. Negative 260 degrees Fahrenheit on average. So if you landed on the nighttime side of the planet, what would happen? You'd freeze to death. And then eventually your body would spin to the other side, thaw out, and then cook like eggs. And then your cooked eggs body would go back to the nighttime side and refreeze, and then it would melt again on this side. So does Earth drop like 900 degrees like this every day? Do we drop 900 degrees at night? No, we don't. So here's my final question about this. Why is it that Mercury drops a greater temperature than any other planet at night? It gets so hot during the day, but it gets so cold at night. Why? Yes, somebody got it. No atmosphere to hold heat. So you probably have heard of the greenhouse effect, which we have on Earth. That helps our planet trap heat for the nighttime side. Also, Mercury rotates much more slowly than we do, and so it has a longer time to cool off. So basically, the lack of an atmosphere makes it so that this planet drops more temperature at night than any other planet. Now, here's my oops, did something, there we go. Here's my last thing I want to say about Mercury. Do we expect to find water on the surface of Mercury? No. Why not? What happens to water in those kind of temperatures? Well, it would freeze on the nighttime side, but that ice would eventually come over to the daytime side and it evaporates, right? So it will evaporate, and because the gravity is so low on Mercury, it won't be able to hold on to that water vapor, and so that water vapor will escape to space. So any water that Mercury may have had at any point would have only lasted a very short amount of time before it was lost to space. But it turns out we did find some water on Mercury recently. Just in the last 10 years, we found ice on Mercury. where would we expect to find ice on Mercury? Where's the only place it could possibly be? And here's something important. It's not underground. It's ice just sitting right there on the surface. Some of you have got... So it can't be the night side, because the night side will eventually come to the day side. And this ice, if we find it now, it must have been sitting there for billions of years. So it's at the poles, yes. It's at the poles. But the poles themselves are hot enough for you to die from the heat at the poles. So the poles in general are too hot for ice to form. So where is it? Well, remember, what's the main surface feature covering the entire planet? What's all over the surface of this planet? Craters. Yeah, some of you guys are getting it. It's craters. There are scarps there, but those aren't as prominent as the craters. So there are craters at the poles. Okay, and what essentially happens is, imagine I'm Mercury, and the sunlight is coming in from over there. You actually can kind of see the sunlight coming in from over there. Imagine I had a crater on my head. If I spun in place, would this crater ever point towards the sun? Would this crater ever point towards the sun, like the bottom of this crater? No, correct. It would never point towards the sun. And if the bottom of that crater never points toward the sun, then that means that the bottom of that crater is always in shadow, and that means the bottoms of those craters will be cold enough for ice to form. That said, if we were to go visit Mercury at those poles and knock down the edge of that crater, when the sunlight came in, it would immediately vaporize that ice. So this is only a very small amount of ice, and we're still studying it right now. Yeah. Any questions?